Now in section 7, what we're going to be doing is solving radical equations, and these are going to be quadratic equations though. Here are the steps that you need to follow. First, isolate the radical. In other words, get the radical by itself, get the radical equals to. So if there's anything outside of the radical on that side of the equation, we need to take it across the equal sign. Show you what I mean by that in just a few minutes. After you do that, you're going to want to square both sides. Now, when you have the radical by itself and you square it, that eliminates that square root. So we're going to square both sides. You'll have an equation now. You'll need to solve it. Now, you need to ask yourself, is this a linear equation or is this a quadratic equation? And back a few chapters ago, we were already solving this kind of equation, only meaning a radical equation, but those were linear equations. These are going to be quadratic. So make sure you know if you're solving a linear or quadratic equation. And then like before, we want to check your answers to make sure you don't have any extraneous solutions, meaning it looks like it should be the answer, but when we check it, it's actually not. And number 1, I do have the radical all by itself. There are no numbers outside the radical on this side of the equal sign, so I don't have to worry about that. What I'm going to do is I'm going to square both sides, because when I square the radical, that eliminates the radical. Well, whatever you do to one side, you got to do to the other, and I've got n squared is equal to 2 minus n. So now I need to solve this equation. The n squared makes it radical, so I need, the n squared makes this quadratic, so I need to get 0 on one side. So I'm going to add n to both sides, and I'm going to subtract 2 from both sides. So I'm going to have n, right, we have 0 on the right side. We're going to write the left side in standard form. And now I'm going to solve this. It'll probably be able to be factored. We're going to want to move through these pretty quickly. So I'm going to have n plus 2, n minus 1 is equal to 0. I'm going to have n plus 2 is equal to 0, and that gives me n is equal to negative 2. I'm going to have n minus 1 is equal to 0, and that gives me n is equal to positive 1. But now I need to check this to make sure everything works out. If I put negative 2 in here, well, I'm going to have the square root of 2 minus negative 2. That's the square root of 4. The square root of 4 is 2, not negative 2. So this one doesn't work. The negative 2 is an extraneous solution. Let's try the 1. 1 is equal to 2 minus, the square root of 2 minus 1. The 2 minus 1 is 1. The square root of that is 1. That does check out. So n being equal to 1 is your final answer. In number 2, I have the radical isolated. I need to square both sides. So I'm going to have x plus 2 is equal to x squared. Now, 0 on one side. I have x squared. A, in that case, is already positive. I'm not going to subtract x squared from both sides. I want that leading coefficient to be positive, so instead of subtracting x squared, I'm going to subtract x from both sides, and I'm going to subtract the 2 from both sides. This I'm going to bring over to the left side, so I have x squared minus x minus 2 is equal to 0. X minus 2, x plus 1 equals 0. I have x minus 2 is equal to 0. That means x is equal to 2. X plus 1 is equal to 0. X is equal to negative 1. Let's go back up to our original equation. If I put 2 here, 2 plus 2 is 4. The square root of 4 is 2. That checks out. When I use negative 1, negative 1 here, negative 1 plus 2 is 1. The square root of 1 is 1, not negative 1. This one doesn't check out, so my answer here is 2. In number 3, everything outside the radical is on the other side of the equation. I don't have any numbers outside of the radical, so I'm going to square both sides. But be careful, on number 3, it's not just enough to do this. We're squaring the entire side, which means we put parentheses around the x minus 3 and square it. So now I'm going to have x plus 3 on the left side. And when I square x minus 3, that means we're going to have to FOIL this. And I get x squared minus 6x plus 9. And now I need 0. Now the x squared I'm going to leave alone because I want a positive 1 here. So I'm going to subtract x, and I'm going to subtract 3. And I'm going to bring all this to the left side. I've got x squared minus 7x plus 6 is equal to 0. Now I'm going to factor this. I'll need x minus 6, x minus 1 equals 0, and I get x equals 6 and x equals 1. When I put in 6 here, 6 plus 3 is 9, the square root of 9 is 3, 6 minus 3 is 3, that checks out. When I put in 1, look what happens. 1 plus 3 is 4. The square root of 4 is 2. When I put 1 here, 1 minus 3 is negative 2. The square root of 4 is not equal to negative 2, so the 1 is out. Our answer is 6. In number 4, I need to square both sides. So I'm going to square the radical. To eliminate it, we're going to be FOILing y minus 1. Y minus 1 quantity squared is y squared minus 2y plus 1 equals y minus 1. I'm going to subtract y from both sides and add 1 to both sides. So I'm going to have y squared minus 3y plus 2 is equal to 0. When I factor this, I'm going to get y minus 2y minus 1 is equal to 0. And that's going to get me y is equal to 2 and y is equal to positive 1. Well, when I put the 2 in here, 2 minus 1 is 1. 2 minus 1 is 1. The square root of 1 is 1. That one checks out. When I put the 1 here, I get 1 minus 1 is 0. 1 minus 1 is 0. The square root of 0 is 0. So this one, in this case, they both work. Your answers are 2 and 1. In number 5, I'm going to subtract 5 from both sides because I need to isolate the radical. Anything that's outside of that radical sign needs to get to the other side of the equal sign, so I need to subtract 5. Let's rewrite the equation. Radical 2c plus 5 is equal to c minus 5. Well, now I need to square both sides, and that means I'm going to be FOILing c minus 5. Squaring the left side just gets me 2c plus 5. C minus 5 quantity squared is c squared minus 10c plus 25. Now I'm going to subtract 2c from both sides, and I'm going to subtract 5 from both sides. So I'm going to have c squared minus 12c plus 20 is equal to 0. Now I'm going to factor this. I'm going to have c minus 10, c minus 2 is equal to 0, and I get c is equal to 10, and c is equal to 2. So in checking these, when I plug in the 10, I get 2 times 10 is 20. 20 plus 5 is 25. The square root of 25 is 5, plus 5 equals 10. That checked out. When I plug in the 2, 2 times 2 is 4, plus 5 is 9. 9 plus 5 is 14. That's not equal to 2, so that one didn't check out. So C is equals 2 is an extraneous solution. I think I might have said that wrong. 2 times 2 is 4, plus 5 is 9. The square root of 9 is 3. 3 plus 5 is 8. It's still not equal to 2. The C is equal to 2 doesn't work. Our answer here is 10. In number 6, I need to get rid of this negative 2. It's negative 2 times the radical, so how will I cancel out the negative 2 there? It's not by adding 2, it's by dividing by negative 2. So those cancel. I get the square root of x over 8 is equal to negative 8. I'm going to square both sides. And when you square both sides, you square the negative as well. X over 8 is equal to 64. When I multiply both sides by 8, what do you get? 512. So x is equal to 512. Now let's put that back into the equation. Now think about this. Look at what we have here. After we square both sides, what kind of equation do we have here? It's linear, isn't it? So we got to be careful about that. This is actually a linear equation, so we're going to get the x by itself, and that's why we have to multiply both sides by 8, and we get 512. Does that work? Negative 2 times the square root of 512 over 8 should be equal to 16. We have negative 2 times the square root of 64 is equal to 16. Negative 2 times 8 is positive 16, so that doesn't work, so this one is no solution. I tell you what, why don't you go ahead and try number 7, 8, and 9 on your own. Maybe you want to do these on a separate piece of paper to make sure we have this right. But when you're done, come back to the video and we'll finish these out. But let's see what you can do with number 7, 8, and 9 on your own. So go ahead and pause the video and come back when you're done. So in number 7, after you add 7 to both sides, you get y plus 2 on the right. Now you have to square both sides. Well, remember the y plus 2 being squared is going to be a FOIL problem. You get y squared plus 4y plus 4. Subtract the 9y from both sides. Subtract the 10 from both sides. And you end up with y squared minus 5y minus 6 equals 0. Y minus 6 and y plus 1, you end up with positive 6 and negative 1, and in this case they both end up working. Plug 6 into the original equation, see if it comes out. Plug the negative 1 into the equation, see if it comes out, and they both do. In number 8, we have the radical isolated. There are no numbers outside the radical on that side, so we're going to immediately square both sides, and when you FOIL the right side, you get w squared minus 8w plus 16. Subtracting the w from both sides, you get minus 9w. Subtracting the 2, you get plus 14. So y squared minus 9w plus 14 equals 0. To factor it, you get y minus 7, y minus 2, which nets you w is equal to 7 and w is equal to 2. Well, the 7 works, but the 2 does not. Plug the 2 into the original equation, and you'll see what I mean. In number 9, we need to isolate the radical, so that means we're going to subtract r from both sides. When you FOIL 2 minus r squared, you get 4 minus 4r plus r squared. Work it out, you'll see for yourself. We're going to now subtract 2 from both sides and add r to both sides. And on the right side, over here now, you're going to have r squared, you're going to have minus 3r, and you're going to have plus 2. When you factor that, you get r minus 2 and r minus 1. And that'll get you r is equal to 2 and r is equal to 1. And in this case, both of these solutions work. Go on to the next page and see what we have there. All right, so in this part of section 7, we still have a quadratic equation, but in this case, b is equal to 0, meaning there is no middle term. Remember, an ax squared plus bx plus c equals 0. Well, this term is gone, so we're not talking, we're just have an x squared term, and then we just have the number that's by itself. Well, what we're going to have to do is isolate the x squared. We're going to take the square root of both sides, and remember that you're going to have two answers. So in number 10, the x squared is isolated, meaning there's no numbers on that side of the equation. So I'm going to take the square root of both sides. X is equal to plus or minus 4. In number 11, taking the square root of both sides, x is equal to plus or minus 12. In number 12, we have to eliminate this 2 first. So I'm going to divide both sides by 2, and I get x squared is equal to 36. Now I can take the square root of both sides and get x is equal to, and again, remember, two answers, plus or minus 6. In number 13, I'm going to add 5 to both sides first. 2x squared is equal to 50. Now I'm going to divide both sides by 2 to get the x squared by itself. So I've got x squared is equal to 25. Now when I take the square root of both sides, I get x is equal to plus or minus 5. In number 14, I'm going to multiply both sides by negative 2. Because negative 2 times negative 1/2 will cancel each other out. I have x squared is equal to 400. Taking the square root of both sides, I get x is equal to plus or minus 20. In taking the square root of both sides here in number 15, well, we can't take the square root of both sides, can't take the square root of 12 evenly. When that is the case, reduce. Do not round this one off. I want you to reduce the radical. So x is equal to plus or minus 2 radical 3. In number 16, taking the square root of both sides here, x is equal to, again, remember, plus or minus. We have 4 radical 2. In number 17, we're going to have to add 6 to both sides first. That gives me 2/3 x squared is equal to 18. Now I'm going to multiply both sides by 3/2 in order to cancel out that 2/3. When I do that, I get x squared is equal to, now what's 18 times 3/2? We get 27. And now when I take the square root of both sides, I get x is equal to, remember these going to be plus or minus, and we get 3 radical 3. In number 18, we're going to add 28 to both sides first and get 2x squared is equal to 40. I'm going to divide both sides by 2. X squared is equal to 20. Now I'm going to take the square root of both sides, and I get x is equal to plus or minus 2 radical 5. In number 19, when something is squared, I can take the square root of it. And that's what we have. We have something squared. We have the parentheses that's squared, so when I take the square root of it, I get the parentheses. Only I'm not going to write the parentheses. I have y plus 6 is equal to, I'm going to take the square root of 1, and I get plus or minus 1. At this point, we're going to write two different equations. Y plus 6 is equal to the positive 1, and then y plus 6 is equal to negative 1. When you subtract 6 from both sides, you get y is equal to negative 5. And when you subtract 6 on the second one, you get y is equal to negative 7. So negative 5 and negative 7. In number 20, this squared means I can take the square root of both sides. I'll get 3h minus 2 is equal to plus or minus 2. Because the square root of 4 is plus or minus 2. Now I'm going to write two different equations, and I'm going to have 3h minus 2 is equal to positive 2, and I'm going to have 3h minus 2 is equal to negative 2. Well, adding 2, you get 3h is equal to 4. Dividing both sides by 3, you get 4/3. In adding 2 to both sides here, you get 3h is equal to 0. H is equal to 0. So your two answers are here are 4/3 and 0. Square root of both sides here. I'm going to have x plus 1 is equal to, square root of 8 is what? Plus or minus 2 radical 2, right? Well, I'll get it right here in a second. Plus or minus 2 radical 2. Now I'm going to write two equations. X plus 1 is equal to the positive 2 radical 2, and x plus 1 is equal to negative 2 radical 2. When we subtract 1 here, we get x is equal to negative 1 plus 2 radical 2. When I subtract 1 here, I get x is equal to negative 1 minus 2 radical 2. Number 22, the area of a square is 225. What's the length of each side? Well, draw a square. The side we'll label S, and the area is 225. How do you find the area of a square? Well, it's side squared. So what is the area? 225. So s squared is equal to 225. How do you solve this kind of equation? Take the square root of both sides. S is equal to plus or minus 15. But we know that the length of a side cannot be a negative, so the answer would be 15. A number squared is equal to 192. What is the number? A number squared is equal to 192. So your number, let's call it n, squared is equal to 192. Well, to solve this, we take the square root of both sides. So n is equal to plus or minus. How do you simplify the square root of 192? You get plus or minus, what is it, 8 radical 3? And be ready on in any kind of standardized test. This question may say a number squared is equal to 192. What is the positive value of the number? So be ready for that. And if it does say the positive value, then of course you'd have to say 8 radical 3. But note that there are two answers here, and that very well could be a question you see on a standardized test. So be ready for that. Other than that, if you have any other questions, you'll ask me or your regular teacher in Algebra 1. And good luck on your assignment.